Hey, 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 hey. Hey, 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 fifth graders. We are entering into our third week of e-learning, which, by the way, I don't know if you got the message that now the new term is remote learning. But either which way, you're learning from home, okay? I'm pretty excited. I know that this is the afternoon and Dr. Mom is just now getting this video done. It's been a full morning with meetings and things like that. So anyway, we're at lesson 27 and our objective is to solve problems involving fraction division. Um, just as you know, in a couple lessons ago, where like Eureka stopped and asked you to solve a few problems to see if you really get it. So that's what's happening in this lesson, okay? All right, so there's no application problem. They go right into the word problems. And I just wanted to remind us of our word problem strategies, okay? So one, model the problem. Like, can you draw something? What can you draw? And what conclusions can you make from your drawing? You know you're going to calculate it to solve it once you set it up and write a statement about what you're trying to answer. And then you're going to see, is your solution reasonable? You know, we are always saying, does your answer make sense? Okay? All right, and so I'm going to go right into the problems. I'm going to try this method where we are looking at the answers and I'm walking you through what the answers look like, okay? So it says, Mrs. Silverstein bought 3 mini cakes for her birthday party. She cuts each cake into quarters and plans to serve each guest 1/4 of a cake. How many guests can she serve with all of these pieces? Okay, or all of her cakes. So, what I'm going to do right now is, oh, it's already up. I wanted you to see. Started to do this before I touched record. I highlighted like here are her 3 cakes, and then she took the cakes and then she cut them into fourths. Okay, so here's a cake that's cut into 4 slices. Here's a cake that's cut into 4 slices, and these are mini cakes, by the way. And here's a cake that's cut into 4 slices. So if we were to count the number of slices here, then there would be 12 slices or 12 fourths. So if you see what the language is here, that there are 4 fourths in one whole, so there are 12 fourths in 3 wholes. You so um, also, the question here is different from before. So this question says, how many guests can she serve with all of her cakes? Another way you could have asked was, what portion, what fractional part is this out of the cakes? And so that's 1/12 in this particular that particular question. But this question is different. And so what happened? They took 3 mini cakes and divided it into fourths, not divide by 4. And that's a little different of a question. I know that I'm not with you to try to, help you one-on-one with this, but I hope that it's starting to make a little bit more sense than before. Okay, let's go on to our second problem here. It says Mr. Pham has 1/4 pan of lasagna left in the refrigerator. So before I even go on, I just want to say that this picture represents that. So this is 1/4 of a pan. So this is the pan. And I'm just going to take the liberty to call this the pan here. Okay. And so here's the pan that someone has eaten this part and this part and this part. And this is the only part that's left. Okay. 1/4 pan of lasagna left in the refrigerator. He wants to take the lasagna that's left. He wants to cut the lasagna into equal slices so he can have it for dinner for 3 nights. Okay, so this fourth of a pan has to be cut into three slices. So here's a slice, here's a slice. Oh, these are big slices. And here is a slice, okay? So then how much lasagna will he eat each night? So that's very, very, very different than if you had an entire pan and you were dividing it amongst, or if you wanted to feed them 1/4 of a slice, how many people could you feed? You see, that's different. Now we're asking about the part. where this question up here asked you about the whole. What are you going to do with all these slices that you cut? And so that's a little bit different. Here, the slices that we cut came from a part. So it's like taking 1/3, and I do want you to see the division and multiplication is the same. So I'm taking 1/3 of 1/4. Okay. The division is I took 1/4 and I divided that by 3 because I had dinner for 3 nights. So 1/4 divided by 3. Well, how much is 1/4? It's actually 3/12. And so remember, if I'm cutting or dividing this piece by 3, I do all of the parts so that I know how much was the entire pan or the entire whole. So 1/4 is the same thing as 3/12. And so because I want 12s here, then this is 1/12. Okay? It's the same thing as saying 1/3 of 1/4, which is the same thing as saying 1/3 times 1/4. Okay? Again, let's revisit it one more time. I think you get this part, that this is the pan. There's 1/4 left. I think you even get that for dinner for 3 nights, you'd have to cut that 1/4 of a piece of lasagna into 3 parts. I think you get that part. So it's like saying then, like, so here's the part that I'm sure you're going to get, or that you may be confused on, is if I divide this by 3, why do I have to divide each of these pieces by 3? Well, because you're trying to understand how much of the pan was eaten just as well. So you're trying to find, this is like 1/3 of 1/4. It's really 1/12 of the entire pan. No, that can be a little confusing, but I think you get that piece up to now. If you get this though, then you understand this answer is going to be 1/12. And so this picture helps you to understand where in the world did the 12 come from if my answer is 1/12. Okay, you can press rewind and digest that a little bit more. Okay, I'm going to keep going. The perimeter of a square. What is perimeter? We talked about this before we left. Perimeter is the distance around, okay, of a square. What do we know about a square? A square has all 4 sides that are the same. And these things are called tick marks. And if I have the same tick mark, that usually lets me know that the things that have the same tick marks are equal, okay? It says the perimeter of a square is, I think that's 1/5. Oh, Dr. Milo can't see that. I think it's 1/5. Okay. The perimeter of a square is 1/5 meters. So they wrote that here. The perimeter is, it is 1/5. 1/5 meters. Okay. 1/5 of a meter. All right. It says find the length of each side in meters. Draw a picture to support your response. Okay. So why did they divide this by 4? Because the perimeter is 1/5. What if the perimeter was like, let's say the perimeter was 25 meters? I'm just going to use a whole number. If the perimeter was 25 meters, then in order to find the sides, well, let's do something that is a little bit more divisible. Let's say that it was 20 meters. So in order to find each side, and if I have the 4 sides that make up the 20 meters, then that means that I will divide this by 4, and I would get 5 meters. Is everybody with me? But my perimeter is not a nice number like 20. It's 1/5. But I'm doing the same thing. So I take 1/5 and divide that by 4. Well, you know how to do this division. Okay? They're just writing it out in the unit language. So 1/5 divided by 4. How much is 1/5? It's 4/20. And so, and I'm going to divide that by 4 to get 120. So the question is, well, how did you know to even change this to 4/20? Because you could change 1/5 into any denominator you want to, because you can multiply it by any number here. Well, the picture kind of gives way. The picture gives way. So let's look and see. Look, here's 1/5. So here's a full meter. Here's 1/5 of a meter. And I'm taking that 1/5 and I'm dividing it by 4. Okay, you see that? Well, I've got to divide each of my pieces by 4 as well. And if you count these up, you're going to get the 20. Okay, so how much is this one little piece? It's 1/20. Each length of the side is 1/20. Well, why don't we test that? Is 1/20? Yeah. So if I add, because I'm doing perimeter, if I add 1/20 up, if I do that 4 times, what do I get? The 1/20 represents the sides, the 4 sides. I hope you're not confused by this, because we said the length of each side is 1/20. So if I have 4 of them, when I add them all up, what do I get? Well, they all have the same denominator, so that means I get 4/20. Well, when I reduce this, don't I get 1/5? I do. I get 1/5. So our answer is correct. The length of each side is 1/20 meters. Okay. So then it says, well, how long is it in centimeters? Well, 1/20 of 1 meter. What do we know about 1 meter? 1 meter is 100 centimeters. So this is like saying 1/20. Remember, I did this before we left. 1/20 of 1 meter, and then 1/20 of, well, what's 1 meter? It's 100 centimeters. And so what they did then, they went from there here. 1/20 times 100 centimeters is 1. You can put this over 1. 1 times 100 is 100. 20 times 1 is 20. And 100 divided by 20 is 5 centimeters. So each side is 5 centimeters. Okay? All right, let's keep going. Number 4, a pallet. This one might be a little tricky. I was reading this one earlier, and I probably would have solved it a different way, but let's go with it. A pallet holding 5 identical crates weighs 1/4 of a ton. I probably would have drawn 5 crates, but let's see what they did. They took they did it from the tons. So they took, okay, they said that, well, here's 1 ton. And so then let's represent 1/4 of a ton. Okay, so there's 1/4 of a ton. So that means that there are 5 crates, 5 crates that represent this 1/4 of a ton. So what they did was they took this and they divided this into 5 pieces, because 1/4 of a ton represents the 5 crates. I think I would have done it differently. I think I would have drawn 5 crates and said that that represents 1/4 of a ton, and then I would have divided each one. So it is the same thing. It's like Dr. Milo would have started with this picture, but I would have drawn out 5 of them. So let's go with this though. If I divide each one of these by 5, this is 1/4. Okay? So what's 1/4 divided by 5? Well, we know how to do this, and this is them using the unit language again. 1/4 is 5/20, and 5/20 is divided by 5 is 1/20. Okay, We know the math of this though. 1/4 times, remember it's keep, change, and then flip. So this is now 1/5. And so how do you multiply this? You're going to get 1/20. Okay. Again, I think I would have done it the other way. I think I would have drawn the 5 crates out, and then you would have been able to see that if you divide each one of them, then you still would have gotten your 20 parts. Okay. And if you need to do that, you can just do that. Here's your, your 5. Here's your pallet that has 5 crates on it. Back to mine. Here's your pallet, and it has 5 crates. So each one of these is a crate. Or you could have just drawn 5 rectangles if you want to. 1, 2, 3, 4, 5, right? So this would represent 1/4 of a ton. So I would have to divide then my 5 this way. And 1, 2, 3, 4. There are 4 parts here, 4, 4, 4, and 4. You would be able to see your 20 parts. I hope that makes sense. That's what I was thinking you would do, okay? All right, and you actually still get the same answers. So my picture would be 5 divided by 1/4, okay? And so you would still get 5 times 4/1, okay? But you would have to know then that that represents 20 parts. What is 1? It would be 1/20. So you can decide which method you kind of understand better. I decided to go with the answer key here, to see if that would make any more sense to you. B says, how many pounds does each crate weigh? I love this because they're sneaking in some measurement conversion here. So this is 1/20 of a ton is how many pounds? Well, how much is 1 pound? 1 pound is 1 ton is 2,000 pounds. So right away they went to 1/20 of 1 ton. But we don't want tons, we want pounds. So 1/20 of 2,000 pounds. That's where they got that from. Okay, now they're going to solve it. 1/20 times 2,000. And we can write that over 1. And then 2,000 times 1 is 2,000. And then 20 times 1 is 20. And so if you divide these two, you get 100 pounds. Okay. If you get this, where there's 20 can go into 20 and 20 can go into 2,100, then you can do that. If not, go right ahead. You'll be safe doing it this way. Okay. 2 more problems. Let's go. Let's go. Number 5. Faye has 5 pieces of ribbon, each 1 yard long. Again, I would have drawn a very different picture. I would have done the 5 pieces. Let's do pink. I would have drawn the 5 pieces of ribbon, but they decided to take 1 yard, and she cuts each ribbon into 6. Okay, so it's the same thing. Here is 5 pieces. Well, no, this is 1 yard that she cuts each ribbon into 6. So what they're doing is they're taking, in this particular case, they're taking the yard, dividing that into 6. And then after you divide that into 6, if there are 6, because it says how many 6 will she have after cutting all the ribbon. So let's see what 1 yard looks like, okay, or 1 piece of ribbon. And really, if you can think about this as ribbon, then that might help you just a little bit, because it says that each ribbon is 1 yard long. So here's the 1 yard. How many? I can break this up into 6 pieces. 1, 2, 3, 4, 5, 6. So I have 6 sixth in 1 yard. I have 6 of them. Here's 1/6 because she wants what? How many sixths will she have? So for this 1 yard, there's how many? 1, 2, 3, 4, 5, 6. There are 6 sixths. I don't know if that makes sense there. Well, let's just think about it like this. Here's a yard. I cut it up into 6 strips. How many pieces do I have here? I have 1, 2, 3, 4, 5, 6 of them. And how many pieces of ribbon do I have? I have 5. Guess what? I got 30 pieces that I can give. How much does each one represent? It represents 1/6. Okay? So she will have 30 pieces, right? And each piece was 1/6 of a yard. Maybe that might be better language. You might want to hit rewind on that one. All right. How long will each of the 6 be in inches? Oh, I love it. I love it. So it's 1/6 of a yard. Again, 1/6 of 1 yard, right? Which is really 1/6 of, well, we don't want yards, you want inches. So there are like 36 inches in 1 yard. Okay, and you get the rest of the math from here. It's 1/6 times 36 over 1, which is going to be 6 inches. Okay? All right, I'm going to keep on going. A glass pitcher is filled with water. Does that say 1/2? Can't read. 1/2 of the water is poured into, or is that 1/8? Oh, that's 1/8. 1/8 of the water is poured equally into 2 glasses. 1/8 of the water is poured equally into 2 glasses. So first of all, I need 1/8 of water. 1/8 of the water. So here's the pitcher. Here's 1 glass pitcher. Okay? And so I need an eighth. 1, 2, 3, 4, 5, 6, 7, 8. I need an eighth. So here is 1/8. And so 1/8 is going to be divided into 2 pitchers. Okay? So I'm going to use just another color here. Let's use blue for water. Right? So here's a half of that eighth. Here's the other half of that eighth. Does that make sense? So if I divided this into 2, I've got to divide this into 2 to see what my new denominator is going to be. Okay? Again, this is just visually trying to help you understand where this denominator of 16 comes from, because I really could say 1/2 of 1/8, and that's 1/16. Or it's like I took my eighth and I divided it by 2, which is 1/16. Okay, where did the 16 come from? Where if I'm dividing this unit in by 2's, I'm dividing each one of these, and if I count all of these pieces, I get 16. Okay. All right, if each glass has 3 fluid ounces of water in it, how many fluid ounces were in the full pitcher? All right, so that means that we never did know how much water, like in ounces. We only knew that 1/8 of it is poured into 2 glasses. So now they're trying to quantify, well, how much is in the glass? Well, now they're saying each glass has 3 fluid ounces of water in it. So that means that for each of these pieces, it was 3. So if this is 3 and 3, this is 3 and 3. So this is 3, and then this is 3. That's 3. And I repeat the same thing here. I've got how many pieces with 3 in it? Well, remember when we divided this, we got 16 pieces. And if there are 16 units here with 3 in them, then 16 times 3 is 48. The other way that they did it over here was saying that 1 unit was worth 6. So this one thing was 6, and how many were there? There were 8 units. So 8 pieces, and I can go back up here. Oh no, I already divided them. But if I were to take out the blues, right? And if that helps you, I will. We'll take out the blues. So look at this. You see this? So this is worth 6. And then how many of these were there? 1, 2, 3, 4, 5, 6, 7, 8. Does that make sense? So it was 2 different ways that you could have looked at it. All right, I'm going to keep going. Oh boy, this looks complicated. It says, if 1/4 of the remaining water is poured out of the pitcher, oh Lord, how many cups of water are left in the pitcher? 1/4 is 1/4 of the remaining water. So really what you have is you have 3/4 that are left. And so 3/4 of 42, when you do all this math, gives you 31 and a half. Well, what is 42? Remember, it was the 48 fluid ounces that you had, and so then they took 6 away because they took. Why did they take 6 away? Why did they take 6? The 6 represents 1/8. Okay, I think we're gonna. I think that they made a mistake on this. Okay, well, if you can figure it out, then I'll go ahead and let you do that. I'll leave this up for just a few minutes so you can see what their solution is. If I go back and look at it and see that they made a grave mistake, then I'll mention it on the next video. Otherwise, you can go ahead and study this. Okay, so I didn't want the video to be too long because we're really going to go into another platform. And so you're going to have to sit and listen to videos there. So I'm just trying to make these videos a little bit shorter than I normally have. All right, take care. Let me know if you have any questions at all. All right.